Hey guys, welcome to another Science Monday. Today's topic, gravity waves. You've probably heard some stuff in the news about gravity waves or something, and maybe you don't quite understand what they are, so that's why I'm doing this video today, to help you guys understand this huge breakthrough in physics. Now, gravity waves were first theorized by Einstein back in 1916, over 100 years ago. Really amazing that they detected these last year, and it's true, it's real stuff. Up until this point, it was only in theory. So what is a gravity wave? It is radiant energy like electromagnetic radiation. So stuff like the visible light spectrum, X-rays, gamma rays, infrared, all that stuff, radio waves. That's all radiation, and so gravity waves are kind of like that. But unlike that, they are not part of the electromagnetic spectrum. They are a gravitational wave that you can detect. Now, as with gravity, you need like a big, solar type masses to see how things react. You're not going to be able to do an experiment on my gravity field because it's so weak. So pretend these are two black holes, all right? These things are like orbiting around each other, and they collide, and like all kinds of really extreme, exciting physics stuff happens. And one of the things that happens is that you can actually detect gravitational waves from that event. So that's where people have been trying to look for some type of crazy event like two black holes orbiting each other and smashing into one another to try to detect this. And that's what they did successfully last year. Super cool stuff. Now, what does this mean? What is a gravity wave? What does that even mean? With visible light, you get it. It's like the stuff that you can see. I understand, super easy. So a gravity wave actually morphs space-time so that distances expand and contract relative to the observer. So to take a look at something in your room, a lamp or a wall or something, and now just imagine what it would be like if that wall or lamp or whatever you're looking at just started to kind of move away from you and then come closer to you. Meanwhile, all of the stuff in between you and that wall is all shrinking and expanding. It would be nuts. It would be, I don't even understand what that would be like. But that's what a gravitational wave in a very extreme sense would look like. However, it's not so extreme and actually incredibly hard to detect on Earth, which is why it's taken us until last year to be able to do it. The technology required to make this measurement is insane. We're talking about making a measurement in a difference of like 1,000th of the diameter of a proton. I don't even know what that means. I did read an analogy earlier that kind of broke it down, made it easier to understand. It said that if you were to detect a similar distance change in the universe, you would take the nearest star to us, not the sun, but the next nearest star, which is like 4.5 light years away. Okay, so you're going light speed, 4.5 years, you get to this star, you detect that it moves the width of a human hair away from Earth. That's the insane amounts of detection level and tech that you need to be able to make this measurement. It's amazing. So these guys were able to do it. Last week they got a Nobel Prize for it. These guys' names are Rainer Weiss, Kip Thorne, and Barry Barish. Congrats to you guys for being so sciencey and smart and probably total nerds, but you got a Nobel Prize, so who cares? Here's a fun fact. Many of you know Alfred Nobel, the founder of the Nobel Prize, as also the inventor of dynamite. But what you may not know is that his brother, in 1888, Ludwig Nobel, died. And there might have been some confusion, and some newspapers thought that Alfred had died. They wrote obituaries. One outstanding one from a French newspaper said, "The Merchant of Death is dead." Now, since Alfred wasn't dead and it was his brother, he didn't like the legacy he was going to leave behind. So he ended up bequeathing his entire estate to found the Nobel Prize in 1895. And then he died in 1896. The device used to measure this is called a laser interferometer. Now, this is pretty cool and a pretty ingenious way of doing this. So basically, you've got this laser, it goes through a beam splitter, and then it goes down two arms. At the end of those arms are mirrors, so the laser travels down, hits those mirrors, and bounces back. When it gets back to that beam splitter, the distances of these arms are exactly the same, by the way. So it goes down, comes back. The wavelength of both of these lasers is the same and cancels one another out, right? So if the distances don't change, the laser beams will cancel each other out and nothing will go to the detector. However, when you want to detect gravitational waves, and like I explained to you, like that object in your room going away from you and coming back, and like actual space-time being morphed around you, that's what's happening here. So when a gravitational wave passes through Earth, it actually changes the length of these arms, and therefore the wavelength of the laser beams is offset ever so slightly. And when that happens, they do not cancel one another out, and some of the laser beam gets to the detector. That's the basic principle of how this thing works. Now, LIGO is the Laser Interferometer Gravitational Wave Observatory. Never gonna say that again. But that's where they set up this experiment to detect it with last year. I think the arms are actually about like 2 miles in length. It's pretty cool, science-y type observatory that they built just for this. Now, what does this actually mean? Well, it means that we have another way to see the universe around us. So that is really exciting. It's like getting a brand new sense that we didn't have before. That's basically what it is. So for your everyday life, not amazing. For the science community and what we can learn about who we are and where we came from, very cool. Anyway, if you want to check out more about gravity waves, I've posted a couple links to some articles below. It's really cool stuff. And now that you understand a little bit more about how it works, you might enjoy learning even a little bit more about how this can affect us as a human species and the things that we might be able to learn from it. So, thanks again for tuning in. If you liked the video, please subscribe, and we'll see you next week.